In this video I am planning to explain the derivative of elementary functions, and the first elementary function are exponential functions. And here we have the term e to the power of x, and e to the power of x derivative is equal to e to the power of x it's going to be, and these are some exponential function formulas. With respect to these formulas we are going to solve our questions. And let me explain this part simply, then we are going to start the solve the question. Firstly, let me remind you about the e. E is a transcendental number like pi, and it is continuous here, 2.71, and it is the base of the natural logarithm at the same time, and when the base is equal to e, it's written as ln, if you remember. Okay, then if we continue e to the power of x derivative again, e to the power of x derivative is equal to e to the power of x, and it is the derivative of the function is equal to itself. Only the function is e to the power of x function. Then e to the power of fx we have here. E to the power of fx derivative like e to the power of x function. First e to the power of fx is written like the previous one. Then the derivative of the power function is going to be here a to the power of x like e to the power of x. A to the power of x times ln a is the extra here, times here ln e. If you think ln e is equal to 1, ln e is equal to, if you remember, ln e is equal to 1, that's why this is e to the power of x times ln e. Also it can be. The last one is a to the power of fx. This is the most general formula of these formulas. With respect to this formula you can write all of them, and these are the conclusions of this formula. Also it can be. So if you memorize this formula very well, you can write all of them easily. A to the power of fx derivative is equal to a to the power of fx times ln a times f derivative x, like this one. Only the extra part we have here ln a. And if you think the number is equal to e, because it should be any real number which is greater than real positive number, it should be because it should be greater than 0. For the a, the definition is positive, it should be, and which is greater than 0. E is a number which is greater than 0 also. If it is e to the power of fx, e to the power of fx times ln a times f derivative x, it's going to be. And here I have put one exercise for the expression here. So for the 3x squared plus x plus 1 derivative, it's going to be equal to 3 to the power of x squared plus x plus 1, I'm writing the function again, times x squared plus x plus 1 derivative times ln 3 is going to be. So it's going to be equal to 3x squared, 3 to the power of x squared plus x plus 1 times the derivative of x squared is equal to 2x, the derivative of 2x is equal to 1, and the derivative of the 1 is equal to 0. So I close this part, times ln 3 is going to be our answer. As you see, it's very easy to take the derivative of exponential functions. If we continue with the exercises, the first exercise is a to the power of x derivative. It's going to be a to the power of x derivative. If you remember, a to the power of x times ln a it was. So the answer of this question, f derivative x, is going to be equal to 3 to the power of x times ln 3, and this is the answer of the question. Here we have the power 5 over 2. So this is a question like the f to the power of n x derivative, which is also the power rule of the chain rule, n times f to the power of n minus 1 x times f derivative x, it's going to be is the answer. So with respect to that one, f derivative x is equal to 5 over 2 times e to the power of x plus 1 to the power of 3 over 2 times e to the power of x plus 1 derivative is going to be, which is 5 over 2 times e to the power of x plus 1 times e to the power of x plus 1 derivative. E to the power of x derivative is equal to e to the power of x derivative times plus 1 derivative is going to be equal to 0. So we are going to leave the answer like this. Okay, the next question. Here, these questions are not difficult, only we have to remember there are two types of functions here, polynomial function and this is the exponential function. So they are, the operation between them is multiplication. So you are multiplying two different functions like f times g function. F times g derivative, so we have to remember this is equal to f derivative times g, f derivative times g plus f times g derivative is going to be. So with respect to this one, x squared times e to the power of x derivative, this is f times g derivative is equal to derivative of first one, x squared derivative times e to the power of x plus x squared times derivative of the second one times e to the power of x, it's going to be. And here we have x squared derivative is going to be equal to 2x times e to the power of x times e to the power of x and plus x squared times e to the power of x derivative. And if you remember, e to the power of x is a function, only the derivative is equal to itself. So the derivative of e to the power of x again equal to itself is going to be. Here this expression is common. Normally we finish the question, but so you can get common term parenthesis, which is equal to e to the power of x times 2 to the power of x plus x squared will be. Okay, the next question. Here we have two exponential function. We can do like this. We can solve the question like the same power, but I want to use here this multiplication rule. Same power rule means if the powers are same, you can write a to the power of n. Let me explain what is a to the power of n times b to the power of n can be written like a times b to the power of n. So e to the power of x times 2 to the power of x is equal to e to 2e to the power of x also. It can be, but here instead of this one, I'm going to use the multiplication rule. Which is here e to the power of f times g derivative is going to be equal to f derivative times g plus f times g derivative is going to be, and e to the power of x. Here e to the power of x times e to the power of x times 2 to the power of x derivative is going to be equal to e to the power of x derivative times 2 to the power of x plus e to the power of x times 2 to the power of x derivative. Okay, here e to the power of x, it's only the derivative is equal to itself, and here 2 to the power of x plus e to the power of x times 2 to the power of x derivative. This is a to the power of x derivative is going to be here. Let me write here a to the power of x derivative. If you remember, it's equal to a to the power of x times ln a it was. So the derivative of this expression is going to be 2 to the power of x times ln 2. Okay, now e to the power of x and 2 to the power of x, these are common. So if I get e to the power of x times 2 to the power of x parenthesis, this expression is going to be equal to, here you have got everything here, that's why you need to leave 1 here, and here when you take e to the power of x, 2 to the power of x, you left ln 2. So this is the answer of the question.